Limits, an intuitive approach. To say that the limit of f of x equals L as x approaches a from the left side, this negative means from the left side here, means that as x gets closer to a from the left side, f of x gets closer to the real number L. Let's take a look at an example here. The limit of the function x plus 1 as x approaches 2 from the left side equals 3. Well, from the left side means that here's our 2 that we're getting closer and closer to. The x is getting closer and closer. And we put in numbers on the left side like 1.9 in and see what happens, and we get 2.9. Then I put in 1.99, which is closer than 2, coming from the left side. Notice from this side here, and I get 2.99. And as I put numbers to get closer and closer to 2 from the left side, this function gets closer and closer to 3. To say that the limit of f of x as x approaches a from the right, that's what that plus means, from the right, equals L, means that as x gets closer to a from the right side, f of x gets closer and closer to the real number L. Let's get an example here. Here's an example. Okay, the limit of 1 over x as x approaches negative 4 from the right side. Well, here's negative 4. I'm going to put in values from the right. I'm going to put in values closer and closer to negative 4. I don't care what happens at negative 4. Just as x gets closer and closer to negative 4 from the right, I might put in negative 3.99 into the function and see what I get, and then put in negative 3.9, put it in the function, negative 3.9 and negative 3.99, and values that are closer and closer to negative 4 but are larger than negative 4, and this function gets closer and closer to negative 1/4. Here we talk about the two-sided limit. The limit of f of x as x approaches L as, the limit of f of x as x approaches a equals L means, notice there's no little plus or minus here, that this is a two-sided limit. In order to say that the limit of f of x equals L as x approaches a exists, then the limit from the left side of a must exist, and the limit from the right side must exist, and these two limits must be equal. You might stop the movie and read that over again. I'm going to take a look at an example here. Here's an example 3. Let's see if there's any more to this. No. Okay. The limit of x squared as x approaches 5 equals 25. And it equals 25 from both sides. Let's take a look and see what we mean here. Here it is. The limit of x squared as x approaches a from the left will equal 25, and the limit of x squared as x approaches 5 from the right side equals 25. And so this is a two-sided limit, and the limits exist and they're equal. And note here, with limits it doesn't matter what happens to the function when x equals a. It only matters as x approaches a, what the function is getting closer to. Although plus infinity and minus infinity are not real numbers, it is often useful to consider them as a limit of a function in that they describe the specific manner in which a limit does not exist. To say that the limit of f of x as x approaches a from the left equals infinity means that as x gets closer to the number a from the left side, the function gets larger without bound. In other words, the function gets bigger and bigger. Example, the limit of 1 over x squared as x approaches 0 from the left. Well, I think we all know what this function looks like, and as I do that, get closer and closer to 0, notice it's not defined as 0, but the function grows without bound. You can also have the limit of f of x as x approaches infinity equals L, or any combination of real numbers and infinity for L and a. Techniques for handling the limits of simple functions. Okay. What do? You get a limit. What's the first thing to do? Well, you could sketch the graph of the function, and then it's you'll have a very visual interpretation of where the function's going as x approaches various numbers. You can plug a into the function. That often works for polynomials, rational functions, trig functions, root functions, log functions, exponential functions on their domains. This works very, very well. You can use the calculator to plug a number into the function that is close to a and possibly see what the function's getting closer and closer to. When you plug a into the function and get an indeterminate form, such as, well, what's an indeterminate form? You plug a in and you get an indeterminate form, 0 over 0 or infinity over infinity or infinity minus infinity. Use elementary algebra to change the form of the function and then try plugging into a. And the next 4 limit movies that you can watch will give examples of some of these.